Failing to understand that an LLM is at its core just a word predictor is the most common rookie mistake. It's the one mistake that ultimately leads to the often repeated question, why is my model spitting out complete gibberish? An LLM operates using something called a deep neural network, which is a very rough approximation of how we think brains work. This network works in layers. Each layer processes the data a little further, gradually uncovering patterns and relationships that aren't obvious in a single pass. Then there are these things called weights, which are essentially importance scores. These weights create relationships between the words we feed the model, projecting them in a bizarre, multi-dimensional space. You can think of weights as little dials that turn up or down the importance of certain words in relation to others. If the model sees cat and meow together often, the connection between them gets stronger. Those dials controlling how strongly words connect are set during the pre-training phase. As the model initially reads millions of pages of text, it learns which words tend to stick together and cranks those dials accordingly. Then there are biases, the model's constant, built-in linguistic nudge, or a thumb on the scale. Think of them as the model's default preferences, how likely certain words are to appear on their own, even before any context is considered. They gently steer the model in particular stylistic or linguistic directions, helping it make more accurate guesses right from the start. The word is a clumsy human concept. And since this is a classy and upscale kind of book, I will now refer to the words as, tokens. They kind of represent the same thing, but also not exactly. Don't worry, it will make sense, eventually. In simple terms, a token for cat might live in this multi-dimensional space close to meow, fur, and whiskers, but be a long way from cucumber or diarrhea. While that definition makes sense to our puny little 3D brains, the actual sheer complexity of the multi-dimensional world is downright spooky. For example, Llama 3, the 7 billion model, has 32 layers, each with a hidden size of 4096. That is the number of dimensions needed to represent each token's position or vector in that single layer's space. By the way, that number 4096 is totally our choice, not some magic rule. So, instead of a point in 3D space defined by X, Y, and Z axis, the token for cat in Llama 3 exists in a 4096 axis space. As the token flows through the model's layers, its representation in that space changes based on the context provided by all the previous tokens.